Hello, hello. I'm Mr. Monty, geometry teacher, Lewis and Clark High School. Welcome back to lesson 13 of our 2020 series, 20 lessons in 20 days to prepare for the end of course exam at the end of May. Last time we talked about similarity. Today, let's see if we can prove similarity. Prove. Given two four-sided objects, we need to prove that they are indeed similar. Well, if you remember last time, the key was the corresponding parts. Which side goes to which side, and then if we could show that the proportion or the ratio was the same for each of those sides, then we could say that these two shapes are indeed similar. So let's start with the corresponding parts. I always start with either the shortest side or the longest side. Let's do the shortest side first. 4 and 8. So we'll write DC and its corresponding part HG is supposed to be equal to, let's go to the next longest one. Yep, the 10 and the 5. So it'll be AD over EH. Then the third side, BC to FG. And then the longest side last, AB EF. The most difficult part is to actually label all the corresponding sides. Now, let's actually put some numbers in and see if we get the same with each one. DCHG, we got a 4 and an 8. We can already see that's 1/2. AD, 5. EH, 10. 1/2, looking good so far. BC, 5.4. FG, 10.8. 1/2. AB, 6. EF, 12. Can you see that each one of these is 1 to 2, 1 to 2, 1 to 2, 1 to 2. So we could write 1 to 2 as a scale factor. Remember when we did scale factors earlier in the year? From a little model to real world, or from real world to a little model, a 1 to 2 ratio. Or each one of these does reduce to 1/2. So finally, we can say parallelogram ABCD is similar to parallelogram EFGH because the corresponding ratios are all equal. Every one came out to be 1/2, 1/2, 1/2, and 1/2. So remember, slow down, label all the corresponding parts, and then find those ratios to see if they match. And if they do, we can show that those two shapes are indeed similar. We'll see you next time when we go to lesson 14.